For this presentation, we're talking about the time series data analysis, or forecasting. Methods used to create a time series forecast in JMP. We used the worker sample example data from the sample library. We analyzed it by using specialized modeling and choosing time series. We assigned the electrical workers to the y-axis, or the time series, and we assigned the date as the input list. Time series will produce the transfer function analysis and the time series basic diagnostics. But if we want to request a smoothing model, we choose one of the many different smoothing models from their list. And there are 7 smoothing model methods. Few of these methods are like simple moving average, simple exponential smoothing, double exponential smoothing, or Winters method. We use the Winters method from the smoothing model, and we get this forecasting model. But if we used another smoothing model like the linear exponential method, we get another forecast estimate model. Another forecast will be provided, and JMP will compare the results of these two methods to decide which method is better, and to compare the different two methods.
Hi, this is Joey Goliardi, and as Gina said before, there are many smoothing models that we can use for time series forecasting. However, we can also use ARIMA methods, which is autoregressive integrated moving average. Basically, in this method, it's a form of regression analysis, and we need 3 inputs that include P, D, and Q. P is the number of lag observations in the model. D is the number of times these observations are differenced, and Q is the size of the moving average window. Next, we go to determining the accuracy of these models. So the accuracy comes from a few things. First, we want to difference the data properly to make it stationary. And basically, differencing the data, we want to remove seasonality and trends. We can use a seasonal ARIMA for this, and very well we'll have to remove all the seasonality from the data, since ARIMA itself doesn't always take the seasonality out of the data. We also want to check the residuals, the residual chart, to make sure there's randomness, white noise, because if it's not random, that means that the data that we have does not explain all the trends in the data set. Lastly, we want to look at the ACF and PACF plots of the different series, and it should fall between the upper and lower limits. If it's not, the data might have to be differenced again, or there may be some other adjustment that needs to be made. Lastly, this is just some of the data I went through in SAS using Dina's same workers data. I tried some of these models up here. Now, note, not all of them would be the best choice of model. I was just trying out different things. Looking at all the models, though, it looks like the Winters additive method seems to be the best. It has the highest R squared. It's got a good lower variance. It's got good AIC, and it's got a high weight to it. So if you can look down here at the predicted chart, this is the predicted area and basically the fan of the data that it falls between. And this looks like just looking at it, it looks like a very possible trend. And then we look down here and we see the residual plot, and there's really not too much except for that first jump, which we also would be able to remove, just differencing the data and playing with it more. Thank you.
Continuing to use the example of the workers data set, we can begin to actually predict out into future periods, which is what we want to do. So before we had chosen our different smoothing methods and determined their accuracy, and now that we've determined that the Winters method was the most accurate, we can make a prediction based on the data. So what we're going to do is we're going to look at the dates on this. And so this one goes monthly, so it's going to be in 12 observation periods, and it's going to be monthly until this 1982 part right here, and it's predicting thousands of electrical workers in this column right here. So what we can do is we're going to, once you click on the smoothing method, the Winters method, it shows the analyzed data right here, and what we want to do is we want to save the prediction formula, and that's going to allow us to not only see what's in the past, but have this formula that's going to tell us what's in the future. Now, after you click on the Save Formula section that we did just before, it's going to give you this table right here. And what you can see is we have the actual data on the leftmost column, and it's going to continue until that date right there, the 1982, and then our data stops. And that's when our prediction formula takes over and predicts into the future periods of what our data is going to look like. And you can see the prediction right here with the standard error and the residuals. And then it also gives you a confidence interval as how accurate that prediction is going to be. And essentially that's how you're going to do that for this data set.